Hi everyone, we're going to finish up this unit with some modeling, which just means word problems and creating equations and working with real life situations with quadratic functions. All right, so if we take a look at the graph, you have your y-intercept, your vertex, which remember is either the max or the min. At the vertex, what's happening here is your maximum height and the time or when that's occurring. So if you're looking at your vertex, if you're looking at that point, when something is occurring is the x, and the height, how high it is your y value. So basically what's happening here is, think of this like, okay, you're launching a ball into the air, it's going to go up and then eventually it's going to come back down. So how high off the ground did the object start? That's going to be your y-intercept. Okay, every parabola has this U shape, but in real life, you're not going to have a negative time or a negative distance. So you're going to start right here at the y-intercept. That's your initial value, your starting point. So maybe this person's throwing it from a ledge and it throws it up in there and then it falls down to the ground. Where it's on the ground, a zero, the positive zero is going to be when it hits the ground. And also, how long is it in the air? Okay, so maybe this is a 5, so maybe the object was in the air for 5 seconds, or it hits the ground after 5 seconds. We wouldn't use this 0. It'd be thrown out because it's being too negative. Okay, you can't have a negative time or a negative distance. So let's look at some examples. They'll look tricky just because any word problem does, but if I give you or you see any kind of equation, we're going to put it right into our graphing calculator and take a look. But let's read through what's happening. All right, the height of an object that's traveling through the air can be well modeled by a quadratic function that opens downward. An object is fired upward, and its height in feet above the ground is given by this function, where t is the time in seconds the object has been in the air. So instead of an x, which would normally be our horizontal axis, they're using t, which is typical because that's your time. And then instead of using y, they're using h to stand for height in feet. So it says make a graph of the object's height for all times. I do want to point out one thing. Regardless of what your equation looks like, that number, that constant value that doesn't have an x attached, that's your y-intercept. So I know without even looking at my calculator that my object is starting 80 feet above the ground. That's the y-intercept. But let's go to our graphing calculator. And we're going to make a table. Typically it's xy, but in this case we're using t and h of t, the height at that given time. All right. They like to throw these on the regions too. All right, and -16. This button has an x, a t, a theta, it has all these things because whatever the variable is, you always want to use that button. Your calculator only recognizes x and y. Don't forget the squared. Plus 64 x plus 80. Now, we're not going to be able to see this graph because it's starting way above the ground. So in this case, we're just going to go to the table. We know it's going to make that U shape. And in your table, you want to scroll down until you see things repeat. I can already see it here. We're just going to graph the positive y values because we can't have a positive height. All right. Or we can only have a positive height. So we have -1, 0. I'm just going to copy all these down. 0, 80. 1, 120. Oh, excuse me, 128. 2, 144. 3, 128. Oh my gosh, I can't even write today. And my email is just going off. Okay, come on. 480.50. All right. So, a couple things I want to point out. Your vertex is right here. I like to circle my vertex. That's going to be the highest point that this object gets in the air. All right. Now, -10. Can you have negative time? No, you can't have negative time. So we're going to throw that out. We're starting at a time of 0. That's your y-intercept. We're going to start right there. That's your starting point. All right, and then plot the rest of these. 1/128. So go after 1 second, it's at 128 feet. Here's 130, so it's going to be just below it. 2/144. 3, after 3 seconds, it's back to 128. 480. Oh, that's nice because it's right on the line. And 50. And again, we started at our y-intercept, which we knew from the equation that it was going to start there. Okay, so now we're going to draw this. Typically, you draw the full parabola, but because of the fact that we're dealing with a real-life situation, we're going to stop at our axes. Doesn't have to be perfect. Oof, got a little rough at the end there, but that's okay. Now, we're not going to have arrows because, again, you can't have negative values. So first of all, I'm going to label this thing h of t, just like any other graph. You can put the whole equation if you want, but you don't have to. All right, what's the maximum height in feet? Here's the max up here. All right, it got up to 144 feet. At what time does it hit the ground? Right here, it's hitting the ground. 5 seconds. And over what time interval is the height increasing? Well, let's see, the object's going up, and then here it turns and goes back down. So between 0, a time of 0, and 2 seconds, it was increasing. Between 2 seconds and 5 seconds, it was decreasing. So over what time interval is it increasing? Was it going up? It started when we started at a time of 0 to a time of 2. After 2 seconds, it started to fall back down. All right, let's try another one. The height in feet of a fireworks shell can be modeled by the function where x is the time in seconds after it's fired. All right, I don't see a y-intercept. So that means it's a 0. That means that, if you were to sketch this, the y-intercept would be 0. So it started on the ground, right? Which makes sense. You light the firework from the ground, it's going to go up, and then it's going to come back down. Not the best parabola, I know, but that's okay. All right, so find the time it takes the shell to reach the maximum height, which would be right there at your vertex, and find the maximum height of the shell. So we're looking for the maximum height and the time it takes to get there. So back to our calculator we go. -16x squared plus 22x, or 224x, excuse me. We'll take a look at the table, find the find your vertex. Look for, I see some repeating. 640, 640, 768, or excuse me, 720, 720, 768, 768, 784. That's your max. 784. So x is the time. It says right above it. So find the time it takes the shell to reach maximum height, 7 seconds. The maximum height is going to be your y value, 784 feet. Wouldn't be a bad idea to just sketch part of that table. 784, and then we'll do 1 point above and below it, just to show that it repeated. Okay, there's your vertex. It tells us a lot. Okay, so let's move on. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is modeled by this equation. They're looking awfully familiar. T is the time in seconds again. Determine the domain for the function in the given context. Explain your reasoning. Well, again, let's type it into the calculator and see what we're working with. I see this negative, so I know it's going to be concave down. And I also don't see a constant, so I know it's going to start at the origin. So if I were to sketch this, I'm going to have a parabola that goes up, and then eventually your object comes back down. So let's go to our calculator and find that vertex. A lot of calculator stuff here. So negative 16 x squared plus 64x. Don't leave the x off. Grab the table. Oh, you can see it there. 0, 0, 48, 48, 264. I'm not going to copy down the whole thing. I just want to focus on that. All right. Actually, why don't we put, it's talking about the domain on this one. So 0, 0, down to 4, 0. Okay, so if we were looking at this, it was in there from 0 to 4. Let's just sketch it. All right, so your vertex was 264. So if it asked about the maximum height of the rocket, it got up to 64 feet after 2 seconds. But this is asking about our domain. Domain, remember, represents your x values. Your x values, in this case, is t. That's your time in seconds. So basically, it's asking you, what is the time in seconds that this toy rocket was in the air from 0 seconds to 4 seconds? Because you can't have negative time. Okay, so it's just asking about domain there. All right. This last question's a little tricky. You're going to see that you can't see the vertex in there, but we'll talk about it. But let's take a look at this equation. Y equals negative 16x squared plus 48x plus 6. This plus 6 is important. That's your y-intercept, which is also the initial height. So the ball's initial height is 6. It says the baseball player throws a ball from the outfield towards home plate. The ball's height above the ground is modeled by this equation where y represents the height in feet and x is the time in seconds. So it's 6 feet. Well, it's a baseball though. All right, so if we take a look at this, it's going to start at 6. It's going to go, again, it's concave down. The ball's going to go up and then come back down. Well, why would the ball be starting at 6 feet? Well, think about it. Baseball player, 6 feet. That's pretty average height. So there's the height, basically the height of your baseball player. How many seconds after the ball is thrown will it again be 6 feet above the ground? Well, why don't we check out our table? Let's start there. Negative 16. And I know this video is a little bit longer, but instead of 2, I figured I would just do 1. 48x plus 6. All right, so let's take a look at the table. I see negative 58, right here, 0, 6. I'm going to copy this table down, actually. So we have x and y again. So it was 0, 6, 138, 238, 3, 6. Your vertex is a decimal, right? It's not flat. The ball's going to go up and come back down. So how many seconds after the ball is thrown will it again be 6 feet above the ground? Here's your starting point. There's where it hits 6 again. So after 3 seconds. All right, typically they're not going to ask you to find the maximum height if it's not going to be shown in the table. But just in case, let's look at how we would do it algebraically. All right, so your vertex is going to be in here. What's halfway between 1 and 2? 1.5. All right, but to actually find that, you could use this formula. Remember, x equals negative b over 2a. And if you look at your equation, negative 16x squared plus 48x plus 6. This is your a, this is your b. So if I did negative b, negative 48, divided by 2 times a, 2 times negative 16, and threw that into the calculator, we'd have negative 48 divided by negative 32, which gives you 1.5, which again is halfway between. If you wanted to actually figure out what the y value would be there, plug it into your equation. So again, taking this equation, we know that x is equal to 1.5, so we'd plug it in. So negative 16 times 1.5 squared plus 48 times 1.5 plus 6. Now you can type, well, first hit second mode, go quit back to the main screen. You could type 1.5 in every time like I did, like I wrote it, or you could remember to tell your calculator to store it, 1.5, store x, enter. So then you can just type x instead, negative 16x squared plus 48x plus 6. Or you could type it in exactly as I have it here with the parentheses. Either way, y equals 42. So that's the maximum height that the ball is going to reach. So if you were to look at the table one last time, that makes sense. 1.5 is halfway between. 42 is between 38. It's a little bit higher than 38. So, okay, so we're going to stop there. There's some practice that you're going to try. I'll probably put in a video to help you with it. It's the last 2 pages of this packet. And then we're going to practice with, actually, this you're going to need the formula for. So this is an optional question. You don't have to do number 2. I'll show you how to do it, but you don't have to unless you don't want to, because it's not something that you, unless you want to, it's not something that you're going to have to do. The other stuff will be fine. Okay? So like I said, we're done with this packet after practice 7. I'll put up a video to help walk you through it. We'll do some together in class, and then we're going to review and finish up the chapter with a test. So watch for those papers if you want to come in and pick them up. You certainly can. But if you have any questions, shoot me an email.